Hello, 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 everybody. Welcome back. We're looking at question number 3 on the 2006 Hypatia contest. A line L passes through the points 7, -1, and -1, 7. Oddly symmetric. Okay, so we've got A, determine the equation of this line. Well, that shouldn't be too hard. We've got 2 points. We can do rise over run and get the slope, and then just plug in one of the points into y equals mx plus b. They haven't specified a type of the line, but I think the one we're all most familiar with is y equals mx plus b. Now, slope, y-intercept form, I think that's what we should go for. They haven't told us they want a particular one. So, get rid of question 2 here. Apparently I went back when I did question 2. Okay, so we want, so we'll do y equals mx plus b. Nice to tell them what form you're going to be shooting for. M is rise over run, and that is the difference in the y coordinates. So 7 minus -1 and -1 minus 7 for the run. Right, just making sure I have those ordered properly. Yeah. So on top we'll get 8, and on the bottom we'll get -8, so -1. Very nice slopes, exactly the sort of thing we'd expect from a symmetric pair of points. 7, -1, -1, 7. Yeah, okay. So m is -1, so now we've got y equals -x plus b. We'll just plug in a point. B, which one was b? Was b 7? Yeah, 7, -1. So this has to be on the line, so y negative of 7 plus b has got to be equal to -1. So this is -7 plus b. Well, bring the 7 over the other side, you'll get 6 is equal to b. So the line has equation y equals -x plus 6. Okay. If we wanted a little extra insurance, plug in -1, 7 here. -1 is 1, plus 6 is 7. Okay. So we've done A part. We've got the equation of the line. Where are we going with this? Well, let's find out. B part. Determine the coordinates of the point P on the line L, so the line that we're talking about, so that P is equidistant from the points A is 10, -10. Odd choice, but okay. And the origin. And so in case we didn't know what equidistant means, it means equal distance from these points. So PA is equal to PO. All right. Well, how can we do this? How can we do this? There are distance formulas. I don't really want to use a distance formula right now, so I'm going to see if I can avoid it for a moment. What does this look like? We've got 7, -1, let's say that's here. 10, -10 is all the way down here, let's say. And -1, 7 is somewhere up here. So our line is going straight down like this. We've got the origin here, and we've got our point A here. And we want something that's sort of equidistant. So it would be sort of some point here and here, so that these two are equal. I'm not seeing any particular geometry. Now maybe I'm just not viewing it or drawing it properly, but I'm not seeing anything particularly helpful here. So I think what I'm going to have to do is use a generic set of coordinates, x and -x plus 6. And we're just going to solve for the x values so that the distance formula gives the same answer for both. So distance formula is based off of difference in the x coordinates is one leg of a right angle triangle. Difference in the y coordinates is another leg. The distance is the hypotenuse. So by Pythagoras we can calculate the hypotenuse. And that's what we're going to do. So let P be at, if you don't like the x's, I'm going to switch it to P, -P plus 6. I find that's something they do a lot in their solutions, but it avoids this x and this x somehow being treated the same. Okay, so distance PO, and I'm not, the distance formula is this. It's square root of the difference in the x coordinates squared plus the difference in the y coordinates squared. And then you square root it. I don't want to square root it. I really don't. I find that tends to mess things up. It makes the calculations a lot harder. So what I'm just going to do is PO squared. If PO is equal to PA, then their squares are going to have to be the same as well. So PA squared, well then, and this is where it's going to get tricky, P minus 10, I think it was 10, right? 10 and negative 10, yeah. Couldn't remember the order there. Plus, and then we have negative P plus 6 minus negative 10 squared. Okay, so I should have expanded the first one out. But yeah, let's expand the first one out, and then I'll redo PA squared. So this is just going to be P squared, and this one is 6 squared minus 6P, so minus 12P plus P squared. So 2P squared minus 12P plus 36. So yeah, I don't want to take a square root of that. So I'm going to just quickly copy that because we're going to have to go to the other side. So 2P squared minus 12P plus 36. For a second there, I thought maybe this could be factored. No, I think it would have to be, we'd need to not have 2 P's there. Anyways, PA squared is P minus 10 squared plus negative P plus 6 minus negative 10 squared. So that's P minus 10 squared plus 16 minus P squared. And that's P squared minus 20P plus 100 plus 256 minus 32P plus P squared. So this is also 2P squared. Now we've got minus 52P plus 356. But OP being the same as PA, that means OP squared is going to be the same as PA squared. So 2P squared minus 12P plus 36 has got to be the same as 2P squared minus 52P plus 356. And we can do some canceling. The P squareds go. Bring the 52 over. 52 minus 12 is 40, so we get 40P. And then 356 minus 36 is 320. And I breathe a sigh of relief because I was worried some of these numbers might not turn out so good, but very quickly we can divide by that and see P is 8. So really only one solution here. So P at 8 and then negative 8 plus 6, so that would be negative 2, is equidistant. And it's the only one. I can't remember if they said there was only one. Determine the coordinates of the point P. Okay, so it wasn't so surprising to them, but I thought, when I saw a quadratics, I thought, yeah, maybe there's more than one P, but it turns out it wasn't a problem. So 8, negative 2, and we're done B part. Okay, so we've only got one more to go, and that's C. So C, determine the coordinates of all points. Okay, so here we might get more than one solution. All points Q on the line L so that OQA is 90 degrees. Okay, so two things pop into my head. One, I think I should draw a picture again. I know, it failed in B part, didn't really give me any insight. But I think a right angle here might be a bit more helpful. Other things I'm thinking about, 90 degrees, I'm thinking, well, we've already been working with equations of lines. Maybe I'll have to bust out equations of lines again. How do I tell if two lines are perpendicular? Their slopes are negative reciprocal. So that's the second thing that pops into my head. Okay, I don't know which is which. I'm going to try and draw a picture and see what I can see. So let's get to it. So we want about there. So we sort of go down like this. And 10, negative 10 is somewhere down here. Actually, 10, negative 10 is on y equals negative x. And maybe that's in some way important. I don't know. Negative x plus 6. And sorry, that passes through the origin, not near the origin, through the origin. Okay, so we want points on here. We'll use purple. And we want them so that we get a nice right angle. So it might be something like that. And it is the right angle at Q. I did read that right. Yeah. So the right angle needs to be at Q. So there's probably one there, and then maybe there's one over here like this. Now, noticing that those lines are parallel has not really helped me in any way. And I don't see how P comes into it. Usually when they structure these questions, you'll often have to use C. In C part, you'll have to use some of the things you learned in A and B. I don't think point P here is really relevant. I think the whole theme for question 3 is just finding points that lie on certain lines. If P did come into it, I would think maybe point P is halfway between these two possible points. But then again, maybe I'm not drawing my picture right. There's only one possible point, or there's a third point that'll work. I'm fairly certain there won't be a third point, though. Okay, so in the absence of this actually helping me in any way that I can see, I think we're going to have to set up some equations. So let Q have coordinates Q, negative Q plus 6. Okay. The line through... So the line OQ has equation... Actually, we don't even need equation. We just need slope. So that might help us out. Has slope rise over run. So that's just negative Q plus 6 over Q. Not particularly interesting. The line AQ has slope rise minus negative 10 over run. And once again, I'm going to make sure I copied A properly. Yeah, negative 10 and 10. So that's going to be 16 minus Q, Q minus 10. Now, OQ perpendicular to AQ means their slopes are negative reciprocals. So that tells me negative 1 over negative Q plus 6 over Q is 16 minus Q over Q minus 10. I think if we rearrange this, we'll get a quadratic. So we'll flip over to the other side. Negative Q over negative Q. Don't forget this minus sign here because we were doing negative reciprocals. And that's negative Q plus 16 over Q minus 10. Let's make sure we copied that right. Yep. Okay. And now cross multiply. So negative Q squared minus negative 10Q. So that would be plus 10Q. It's got to be equal to... we'll just write it out. So that'll be Q squared, and then minus 16Q, minus 6Q, and then plus 6 times 16 is 96. Yeah. So I'll simplify that. Q squared is minus 22Q plus 96 is equal to negative Q squared 10Q. We'll bring it all over to one side, so 0 is 2q squared minus 32q plus 96. Divide by 2 on both sides. Q squared minus 18q plus 48. And, I can factor that in my head. I was about to say we have to use the quadratic formula, but negative 12 and negative 4 will work. So q equals 4 and q equals 12 are the solutions. And that tells us that q can lie at 4. Negative 4 plus 6 is 2. And 12, negative 12 plus 6 is negative 6. And those will give right angles. And we'll change that to an OR. But that does it for question 3. Not the smoothest question. I'm never a big fan of line manipulation and things like that. It's necessary. I personally always find a little bit of coordinate algebra or coordinate geometry a little inelegant. But I was happy with that question. Not so bad. So we've got one more question to go, and that'll be question number 4 on the 2006 Hypatia. I will see you guys there. Thanks for watching.